Greetings to everyone who is watching my video. Don't forget to subscribe after watching my video. We are looking at the simplex method of solving linear programming problems, and we are given a problem below to solve using the simplex method. The first point to note is the given problem must be in standard maximization form. It must be in a canonical, it should be in a canonical maximization form for you to solve using the simplex method. Yeah, it should be in a canonical maximization form. Also, the b's should be bigger than or equal to 0. So we are given our problem is here. It is already in canonical maximization form. Now what do? You convert it to standard form. If in case the problem was in a canonical minimization form, you first convert it to canonical maximization form, then you convert it to standard form. That's why I had my objective function here, and in my first constraint it was less than, so I added a slacker variable to make it equal to 10. So I chose to add it here on the objective function also. Even on my second constraint, I had less than or equal to, so I added a slacker variable x5 to make it equal to 4. I added it on the objective function also. Even on my last constraint, I add less than or equal to, so I added a slacker variable x6 to make it equal to 1. So I put it also on the objective function, but with 0 coefficients. Hope you're getting me. This one means I have not changed anything in the objective function. I've just added these 0 coefficients of x4, 0 of x5, and 0 of x6 from the slacker variables. You also note that the slacker variables appear once. They are appearing once in the constraints. Therefore, we call them basic variables when we are dealing with the simplex method, because they are appearing once in each constraint. We have x4 once, we have x5 once, and we have x6 once. Let us now go to the meat itself. So we have Cj. Cj is the coefficient of the objective function. So we have negative 7, 9, 3, 0, 0, 0. So I have negative 7, 9, 9, 9, 3, 0, 0, and a 0 here. Okay, so this is x1, x2, x3, x4, x5, and x6, and x6. Now let us go to the coefficient of the constraints. We have 5 here. We have negative 4, negative 1, 0. It's a 0. It is a 1. It's 1 here. 0, 0. Come to this, we have 1, negative 1, 0, 0 coefficients. Here is a 1. Here, x6 is a 0. Here is we have a 4. Here we had a 10. These are the b's. Yeah, these ones here. Hope you're getting me. Yeah, the b. This is a 1. If we got the last one, we have negative 3, we have a 4, we have a 1, on 3, on 4, we have a 0, on 5, we have on 5 here, don't have 0. Do we have on 6 here? Is here 1. If the b is a 4, is a 1. Is that clear? So we see that now x5 appears once, x6 appears once in all the constraints, x5 appears once in all the constraints, x1 appears once in all the constraints. Therefore, x4, x5, and x6 are what we call the basic variables. So they are the basic variables. We have x4, x5, and x6. What are their coefficients? We have a 0, a 0, and a 0. Those are the coefficients of the basic variables. Is that clear? Is that clear? Yeah, that is it. So now here we shall have what? So these ones, when you sum 0 times this column and 0 times this column, 0 times this column, that's what we call the zj. The zj. So we shall have here zj minus Cj. Zj minus Cj, which is this times this 0, this times this 0, this times this 0, minus 7. So this is the Zj minus Cj. So which I have here the 7. So this times this 0, this times this 0, this times this 0. I'm saying this times this 0 plus this times this 0 plus this times this 0, minus 9. Shall have a negative 9. Is that clear? Shall have a negative 9. Shall have here negative 3. Hope you've learned the trick. 0, 0, 0, 0. Also here 0, because I have 0 plus 0 plus 0 minus a 0 here, because I have nothing there. Alright, so now after having reached here, we now look at the most negative on our Zj minus Cj. The most negative. That's said we look at the minimum of Zj minus Cj. The variable that enters the basis. We look at the minimum of Zj minus, and actually this is the minimum of Zj minus Cj. So shall have here, these are the b's. Here we always have the ratio. So since this is the most negative, which is the minimum, so I now look at this column. Since I have a negative here and a negative here, these ones I don't need them, because the variables is bigger than. So since I have a negative and negative, I just ignore those ones. So it means this one, it is what I'm interested in, implying that where I have x6, I'm going to replace it with 9x2 because of this positive here. If I had a positive here, I now get the ratio, but I'm not to get the ratio. Why? Because I have a negative 4 and a negative 1. Is that clear? Yeah. So implying I'll have on my last column is where I'm going to substitute this one will leave the basis, and I'll substitute it with this. So I'll have 9, x2. Coefficient is 9, x2 is now the basic variable, because it is this one here. These are negatives. I can't have coefficient of basic variables being negative, so I look at this positive here. Since I'm looking at x2, it means I should have a 1 here. Where there is x2, I'm next way. I should make sure I have a 1 here. What do I do on this column to have a 1? I divide by 4 everywhere. So I have negative 3 over 4. 4 over 4, you get a 1. We have here 1. We have 1 over 4. Am I clear? We have 1 over 4. We have 1 over 4. We have a 0 here. We have a 0 here also. We have 1 over 4 here. We have 1 over 4 here also. Is that clear? Just dividing this row, dividing this row by 4 to make sure I have a 1 here, because I'm looking at x2. I'm looking at x2. How do I get the x5 now? When I'm looking at x5, I need to make sure I have a 0 here under, because I should have 1 here and 0 elsewhere. So I should make sure I have a 0 here, and also on the part of x5 here, I make sure I have a 1 here. How do I ensure that? So this row, I'm using this row, and now this row here. So I have if I get negative 1 and add to this, I get a 0. But do I remain with the 1 here? Yes. So I have this row plus this row to get this row. Okay? This row plus this row to get this row. So I have negative 1 plus 1 to get a 0. I have a 1 plus 0 to get a 1. So I will have let me hope I'm clear. So we said we are getting this 0 plus this 0 to give me this. So I have 1 plus negative 3 over 4, you get 1 over 4. Negative 1 plus 1, you get a 0, because I wanted the 0 here. We have this 1 plus this, you get 1 over 4. 1 over 4. This plus this, you get a 0. This plus this, you get a 1. This plus this, you get a quarter. And then this plus this, you get 17 over 4. Let us go to how do I get the x4? How do I get x4? x4, I said when I have a 0 here, I need a 0 elsewhere. How do I need a 0 here, and then on the column of x4, I need a 1 here. How do I do that? I use this row, remember, and now this row 1. So when I said this negative 4, so I multiply this row by 4 and I add to this. Are you getting me? So I'll have negative 4 plus 4 times row 1. Negative 4 plus 4 times row 1. So negative 4 plus 4 times 1, you get a 0. 5 plus 4 times this, what do you get? You get a 2. Negative 1 plus 4 times this, what do you get? You get a 0. 1 plus 4 times this, you get a 1. 0 plus 4 times this, you get a 0. Also, now here I have 0 plus 4 times this, you get a 1. Am I clear? Then you have this 10 plus 4 times this, you get 10 plus 1 over 4 times 4, you get 11 here. Is that clear? Now you got the zj minus cj. So you sum 0, this one give me a 0, so we have 9 times this minus 7. I'll get a quarter. 9 times this minus 9. I'll have a 0. So the same way, I'll have negative 3 over 4. This times this minus that, I have a 0. I have a 0 here. I'll have this times negative 9 over 4 minus 0 here. So I'll have this times 9 over 4 minus 0 here. I'll have 9 over 4. 9 over 4. So this one is one negative remaining, so it is actually the most negative. You get me? It's the most negative. So which means of these two is where we are going to have one of it leaving and being replaced by 3x3 of these two here. One of it will leave and will be replaced by 3x3. How do I identify the one which is going to leave? That's now where I look at the ratio. Since I've identified this, get this, divide by this, you get 17. This divided by this, you get a 1. Is it clear? So this is now the list. So we look at the minimum. That's why we look at the minimum. We look at the minimum. The minimum of x bar divided by yki. The minimum of this is what we look at here. So now the minimum is 1, which means this column is going to, this 9x5 is going to be replaced by 3 by 3x1. So this last one here is going to be replaced, which I'll have 3. It's going to be replaced by 3x3. This one here with its coefficients 3x3. So I'm here looking at that. Then I'll come here, have 3x3. I should have a coefficient. I should have 1 here. How do I do that? Multiply throughout by 4. Multiply throughout by 4, which I'll get negative 3, 4, a 1 which I want, 1 which I want here, 0, 0, 0. What about here? 0. What about here? 1. How about here? 1. Okay, now I need to get the x5. On x5, I need to have a 0 here, and then at x5, I need to have a 1. How do I do that? So I'm using this row and this row of x5. I need a 0 here. What do? Divide here by 4, divide this row by 4, and get now this row minus this row divided by, which is divided by 4. So I'll have 1 over 4 minus 1 over 4, you get a 0. Will I remain down here? Yes. I'll have 1 minus 0 over 4, you get a 1. Okay. So here I have 1 over 4 minus 3 over 4. I'll have 1 over 4 minus 3 over 4. What do you get? What do you get? 1 over 4 minus 3 over 4. You get 1. Is that clear? 0 minus 4 over 4, which is actually negative 1. 0 minus 0 over 4, which is actually a 0. Are we together? Which is a 0. 1 minus 0 over 4 is a 1. 1 over 4 minus 1 over 4 is a 0. Is a 0. And here 17 over 4 minus 1 over 4. What do you get? 17 over 4 minus 1 over 4 shall have 16 over 4. 16 over 4, which is actually a 4. Am I right? Yeah. How do I get 0x4? I need to have a 0 here, and on x4 I need to have a 1. So I'm going to use this row and this row as usual. You always use this row as our reference row, this one. Then and that row. If I'm looking at this, I use this row and this. If I'm looking at this, I use this row and this original row. This row and this row here. So I need a 0 here and a 1 here. How do I do that? I need a 0 here. I have already a 0. I need the 1 here. I have already a 1. It's already there. So there is no need of doing an operation. So I just copy the way it is. I'll have to 0, 0, 1, 0, 1, 11. So let us look at now the zj minus cj. Shall have 0, 0. This is negative 9 minus 7. What do you get? You get negative 2. This is 12, 0, 0. This is 12 plus 0 minus 9. You get a 3. This one, 3 minus 3, because these are zeros, so you get a 0, a 0. Here, a 0. This is times this is 3 minus 0 is a 3. This times this is a 3 minus 0 here, because here there is nothing. Up here there is nothing here, so I'll have 3. Are we together? So which one is the most negative? I have only this, so it is the negative only. The negative. So what is the ratio? So now this is negative, so which means this is already negative. I don't look at it. Now you can do and 1. Which one is going to be replaced between this and this? Which one is going to be replaced? How do I identify? Get the ratio. This divided by this, you get 5.5. This divided by this, you get a 4. So this is the smallest. So this one is going to leave the basis and will be replaced by, it will be replaced by negative 7x1. So let me close here. Let me close here. So this one here is this one is leaving. This one here is leaving, and it's going to be replaced by negative 7x1. Negative 7x1. So meaning, once I replace it, it means I want a 1 here. I want a 1 here, and actually it is already there. So I don't need to do any operation. It's a 1, negative 1, 0, 0, 1, 0, 4, 4. Yeah, so I have a 1 here already. That's why I didn't carry out any operation, because I always whatever I have here, I should have a 1 in its place. A 1. Okay. Yeah, that's why I didn't carry out any operation. Now, how do I get the x4? How do I get this one? It means I want a 0 here, and in x4 I want a 1 here. So I'm going to use this row as my reference row and the original row. So multiply this times 2, and How do I get a 0 here? So 2 times twice this. 2 minus twice this. I get a 0. Will it give me 1 here? So 1 minus twice this, I'll get a 1. Is it clear? So 0 minus twice this, I'll get a negative 2. 0 minus twice 0, I get a 0. 1 minus twice 0, I get a 1. 0 minus twice this one, I get a negative 2. 1 minus twice 0, I get a 1. This 11 minus twice 12 minus twice 4, which is 8, I get a 2. Okay. Now how do I get 0x5? How do I get 0x? I've got this not 0. How do I get the 3x3? How do I get the 3x3? So I'll have here I need a 0 here, and here I need a 1. I need a 1 in the place of x3 up here. I need a 1. How do I do that? This is my column, and I'm going to use this. So multiply here by 3, add to this. I get a 0. Will I get a 1 here? Multiply here by 3, add to this. I will get a 1 actually. So we have 3 times 1 is 3, plus this, you get a 0. 3 times negative 1 is negative 3. Negative 3 plus 4, you get a 1. 3 times 0 is 0. 0 plus 1, you get a 1 which you wanted. 3 times 0 is 0. 0 plus 0, you get a 0. Okay? 3 times 1 is 3. 3 plus 0, you get a 3. 3 times 0 is 0. 0 plus 1 is a 1. 3 times 4 is 12. 12 plus 1 is 13. Is that clear? Yeah, it is very the best. So we have now the zj minus cj. How do I get the z minus cj? So this times this plus this times this plus this times this minus these ones above. So we do the same for this, and for this. So we shall have here 0. 3 times here also 0. We shall have negative 7. Minus 7. Minus 7 above here. I get a 0. This is 3. This time this is 3. 3 plus negative 7. What do you get? 3 plus negative 3 plus. This time you get 7. 3 plus 7, you get 9. 9 minus this 9 here, you get a 0. No. 3 times this one is 3. Is it clear? 3 plus 7, you get 10. 10 minus 9, you get a 1 here. So you repeat the same for these ones. You will get a 0 here, you get a 0 here, a 2 here, a 3 here, and the 11 here, 11 here, 11 here. So as once you reach a point where the zj minus cj are all greater than 0, then you have already determined the solution. So you shall have x4 is equal to x1 is equal to 4, x1 is equal to 4, x3 is equal to 13, x3 is equal to 13. This one here is our z bar, therefore z bar is equal to 11. So the rest of the x's are 0, so we shall have x5 is equal to 0, x6 is equal to 0, x2 is equal to 0. So in bracket, so this is the optimal solution. This is the optimal solution. Thank you for watching. Bye bye. Don't forget to subscribe.